Hello everybody, and today I'm gonna talk about projectiles, or the path of the projectile, the mathematical equation for the projectile's path. Now, yes, and I'm gonna make that. We're gonna see what's the mathematical equation for that. We're gonna make that equation into a graph, and we're gonna see that and then in the video. Now let's think, what variables can a projectile have when thrown? Well, there's gonna be an initial speed, isn't there? Because, well, yeah, initial speed, initial velocity. So I'm gonna write V for velocity. And then also there would be the angle which the projectile has been thrown in. So A for angle. And then also the time which flows, which is going to affect the projectile, because when I have thrown something, when the time hasn't passed, it's gonna be at in my hand. When time has passed a little bit, it's gonna be over here, and if time has passed a bit more, it's, well, I don't know, over there. And then, yes, anyways, time is an important variable too. T for time. And then also the thrown height. You can throw it over here, you can throw it over here, or like that, or you can kick. And yeah, so height, vast. Anyways, vast is the variable. And yeah, we are going to make that make vast sort of getting smothered into that equation for the projectile's path. The vast for the path. Anyways, now you need to know cosines and sines as well to know this, to understand this equation. Now, what you need to know is, what is cosine and sine? Cosine is, well, before that, let's draw a coordinate plane thing, and then there would be the path of the projectile. It would go like this, and then if I look at a very small part of the whole thing, if I look at it closely, there would be a line, which, well, it would this diagonal line. This diagonal line would these diagonal lines would make the whole thing up. The whole thing. Yes, make the whole thing up. And then, now, let's say, well, to put something in a graph, or put some, to put something in a graph, you would need the coordinates, like the x coordinates or the y coordinates. But we only know the speed of this thing, which is v, initial velocity, the velocity is v, and we only know the let's say we only know the velocity and the angle it has been shown. We want to know this spot, the coordinates of this dot, and then so what you can do is, for the x coordinates you will need cosine, which is well, let's say there's a triangle with one side 90 degrees, and then cosine is well, let's call this side v because this is v, velocity, similar things, and so it would be the floor part of the triangle over the velocity, or the side part. That would be cosine. And when the triangle has the angle A, you would write if the angle is A and the side part of it is V, you would write V cosine. You write cosine like this, cos, and then some brackets, and then A, the angle in it. Now, this, using this, you can get the x coordinates of this dot. And then, now what about the y coordinates? This would be the cosine, or x coordinates, and the y coordinates is, you can get it by using sine. Now sine is, let's say this is height. Let's just say it's y, and this is v, this part. This part is v and this part is y, let's say. And then what you get is y over v. That is sine. You write sine like this. And then, similar to cosine, if the side part is v, and that triangle has the angle A, you write it like v sine, and then the angle A. Now it's like that. So basically, we will use cosine. For the x coordinates, and we will use sine for y coordinates. And maybe I would draw this over here too, because of gravity, things go up and then fall. And now let's think about the equation for the x coordinates first. Now, wait, I'll draw this thing again. We are gonna talk about x coordinates this time, not y coordinates. Only this part. It's only moving this way. It's only the x coordinates, so it doesn't go up and down. We're not gonna think about the up and down. We're only gonna think about this part. Like, let's say there's a light source over here. Gonna draw a sun. It's similar to thinking if there's a ball over here. It's similar to, it's easy to think like the thing as the x-coordinates, like the shadows of the ball, like that. It's just moving this way. We're only gonna think about the x-coordinates right now, so then the x-coordinates doesn't get affected by gravity, does it? And the drag from the air, you don't get well, in the x-coordinate, the projectile does get the drag for the force of drag by the air around that ball, but have I said it before? Said it before. Why we are trying to get the equation for the projectile's path is trying to get the angle that throws the projectile furthest. We're trying to get the angle for the furthest thrown. We're trying to get the angle to angle that is able to throw the projectile the furthest. And the drag force of the air depends on the velocity of the thing that is hitting the air, and the surface of the thing that is hitting the air, and also the density of the air. But there isn't anything about angle in it, so we basically don't need to consider air, the drag force of the air, basically. So we are just gonna, as I said, write the speed of the x-coordinate, the projectile speed in the x-coordinate. Yes, then as I said, it would be v cosine A. A is the angle. As I said, the speed would be this, and to get the length it has traveled, what you need to do is multiply t into the speed, t into the t times velocity, v. So because velocity is space, or the length has something traveled over time, and so if you just multiply t into both sides, you just get vt equals s, which is velocity multiplied by time equals the space it has traveled. So to get the length that the projectile has traveled in the x-coordinates, you would do this. multiplying t into the whole thing. And this is the equation for the x-coordinates. So let's write it over here. X equals, the x-coordinates equals v cosine a times t. Now, with the x-coordinates done, let's think about the y-coordinates. Yeah, the y-coordinates, they're quite a bit more complicated and hard, but quite interesting as well. Now, how it is, now the equation for the y-coordinates, it's like this. Well, before that, I need to explain the thing about accelerating. Firstly, the velocity is, as I said before, when I was explaining this x-coordinate, when I was explaining the x-coordinates, velocity is space or the length over time. And then acceleration is, I think normally people write acceleration as the lowercase a, but I'm using a for the angle, so I need to write it as the capital A. Now, acceleration is velocity over time. So what this means is velocity is the movement over movement on the space, movement of the space over time. Acceleration is movement on the velocity over time. I hope that makes sense to you. And then what it is this equaling, well, this is basically s divided by t. And then this then becomes s divided by t again. So it's squared. Now, that's acceleration. Now, then this would be a bit more easier to understand. The equation for accelerating is this. The initial speed, initial velocity, plus like that, and that, the acceleration, and then time multiplied by time. These are brackets, not C and upside down, not C and upside down, right side left C. Now, this, how it works is quite interesting. Now, this part you would get, it's just the initial speed, no matter if it's 0 or if it's 100. Now this part is the very, very interesting part. Firstly, this is the acceleration, a. Now you multiply t into it. What do you get? If you multiply t into it, you get velocity. So basically, what it is you're making you're trying to get the velocity of the acceleration. Does that make sense? It's more of a yeah, let's call it the velocity of the no, wait. It's the velocity that was made by the acceleration. Let's take an example, like something is accelerating at 10 meters per second squared, because that means accelerating, and time has passed 0 to 10 seconds. Now, then you want to know how much time. What speed is the thing that is accelerating? What speed is it traveling after 10 seconds? Then you multiply multiply 10 seconds. No, that's 18. Not 10. 10 seconds. Now you multiply the time into the acceleration. Then you get, well, 100 meters. And this is dividing and this is multiplying, so we can erase the squared part. You get 100 meters per second. Is this accelerate? Is this showing the acceleration? No, it's showing the velocity that the thing accelerating is traveling with. Now, so basically you're getting the both sides, both velocity. You're making both sides about velocity and then multiplying time. And multiplying time and making the and getting the length of the thing that has accelerated. I mean, the length that the thing accelerated has traveled. But you might wonder, you will wonder, why this thing is over there. Why do we divide this by 2? Because let's think of this example again. Has this thing that accelerated did this thing that has accelerated always move at this speed? No, because time has passed and the acceleration must have been from 0 to the speed must have been from 0 to 100 meter per second, but let's just write it meter per second. Now it has changed, so what we are doing is just cutting it in half and getting the average speed of the whole thing to make it simpler. So yeah, cutting it in half, or just getting the average of this thing. So then it becomes much more, then it makes much more sense, because if you multiply this into it, the distance it has traveled with the initial speed, and if you multiply this into this thing, then you get the distance it has traveled with acceleration, and then you combine these two, and then it becomes the thing that accelerated with the initial speed. I mean, the length of the thing that has accelerated with initial speed initial speed. I hope that all makes sense to you. And now, that's the equation for the length of something that has accelerated, not the y coordinates. But it's quite similar though. We're gonna use this equation. Now, you multiply t into both these things, so you get then velocity times t plus half of the acceleration times t squared. Now this thing, now let's turn it into the y coordinates. Now the gravity of the Earth makes things accelerate downwards at 9.8 meters per second squared. So then we can change the acceleration into 9.8, and then we multiply, not multiply, well, it's sort of multiply. We divide 9.8 into 2, and then it becomes 4.9 t squared. And in the graph, when it's going down, it's basically minusing. Does that make sense? Contracting. I think that makes more sense. You're just contracting, basically. I'm gonna say minusing. I don't for some reason. You minus this amount. You add the negative. I don't know how to say it, but I hope you get it by this equation. Now you're adding negative amount of adding a negative number, so then it becomes just this. Yes. Now, then, as I said before, velocity is, not velocity. In the y coordinates, we're gonna use sine. So, if I erase this and then change it to sine, then it would be v sine a, like that. And then the velocity and the angle and the time variables has been used, but we didn't add the throwing height into it. So we add height. It's simple like that. The height is just like that. And then we made both equations for x and y. So now we combine these together, and then what happens is, well, when you wanna put something into a coordinate plane thing, what you do is the brackets and then the x coordinates and then the y coordinates and then closing the brackets. It's like that. So then the equation for the whole thing becomes I'm gonna write it a little bit big this time. V cosine A times T, and then is it too big? It might be a little bit too big. V sine A time T. It's not plus, it's minus. Minus 4.9 T squared, and then plus H. That's the equation. Now, let's put this equation into a graphing calculator, a graph calculator website thing. Let's get on to it. Now let's I'm in Desmos graphing calculator, and now let's write the equation in the brackets, and then V cosine A, and then T, and then that, and V sine A, and then T, minus minus 4.9, and then minus 4.9 T squared plus plus H. Now that's the equation, and then let's say the velocity is 20 meters per second. So let's write 20 into it, and then now let's say the angle is 45, and then the thrown height is 2. And let's see this graph from time 0 to time 10. Now you see something like this. The ball is thrown here at a 45-degree angle, and then it goes zoom and lands over here, I guess. But in graphing calculators, I guess there's nothing called floors, and it's like that. Well, just falling constantly. Now we have seen this in Desmos graphing calculator. Yeah. And now we derivated this equation, and then we saw this in Desmos graphing calculator. So I guess it's time to end. Thanks for watching, and goodbye. And also, I would like it if you would subscribe to my gaming channel. Bye!